Ladies and gentlemen, we're going to be talking about Chapter 7 for Trig identities. And that's our goal today, is we're going to establish an identity. Okay? Basically what we're going to do today, you guys remember back in the day in geometry? You remember geometry? Yeah? You remember proving triangles are congruent? Like side, 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 side angle, side. You remember how that was awesome and fun? Right? Well, that's called a proof. And this is kind of like a proof of algebra. This is like an algebraic proof, okay? But we're going to use trig functions to do it. I promise this is going to be fun. Mr. Gotsch does this all the time. All the time. I do this in the basement. I just make up little identities to prove, and I work that out on my chalkboards. I have wall-to-wall chalkboards in the basement. It's fun to do. All right, so here we go, guys. We're going to establish an identity here, okay? Well, there's some basic trig identities that we should be aware of, and I showed you guys these back in chapter 8.1 when we're doing just SOHCAHTOA. We should know the buddies, the reciprocals. We should know cosecant is 1 over sine. We should know secant is 1 over cosine, and cotangent is 1 over tangent. You could also say the opposite, that sine is 1 over cosecant. You could say cosine is 1 over his buddy secant. And then you could say tangent of theta is 1 over cotangent. So those guys are reciprocals of one another. The other thing we talked about in chapter 8.1, we talked about tangent being sine over cosine. And because cotangent is the reciprocal of that, cotangent is cosine over sine. Okay, we're going to use all those quite a bit. Those are just your basic trig identities. Last but not least, some other identities I'm sharing with you guys today, and I showed you guys these in the last chapter just briefly. We talked about anytime if you have a ratio of sides and you have sine of that angle and cosine of that angle, if you square those two and add them together, they will add up to 1, always, always, always. So sine squared plus cosine squared is 1, is what we call a trig identities. Okay, this is based off of like a squared plus b squared equals c squared, Pythagorean theorem. So this is a Pythagorean identity. And these other two here are basically derived or came up with by dividing all these guys by cosine squared. So if I take sine squared divided by cosine squared, that's tangent squared. If I take cosine squared and divide it by itself, I get 1. And then 1 over cosine squared is secant squared. And then if I take all these guys and divide by sine squared, I get this. Sine squared divided by itself is 1. Cosine squared over sine squared is cotangent squared, and 1 over cosine squared is cosecant squared. So that ends up to be that Pythagorean identity. Okay? So we're going to use these throughout the day and try to use basically substitution. We're going to try to get these like pieces to fit together. It's like a puzzle. Okay? You guys ever played Tetris back in the day? Yeah, we're trying to get these like blocks to fit in nice and pretty. Okay, that's our goal for today, is to get this all to nicely fit. It's kind of a puzzle. I like this stuff. Okay? So as I take a look, it says two functions f and g are said to be identically equal if f of x is f equal to g of x. Such an equation is referred to as an identity. An equation that is not an identity is called a conditional equation. Well, what we're trying to do is we're trying to prove that this side is equal to that side. When you do something like this, you always want to stay on your side. We're trying to get the left side to look like the right side. So that means that we can't like add over to the other side or divide over to the other side. You're not supposed to do that. You're just supposed to work on one side or the other. Okay? Now, usually the side that you work on is the bigger of the two sides, and usually that's going to be on the left side. But it's not wrong if you want to get the right side to look like the left. Okay? So here we go. I'll show you what I'm talking about. So this is my equal sign. I'm not going to cross over this equal sign. And we're trying to get secant times sine equal to tangent. Okay? Well, again, anytime I'm trying to get these things to fit together and work together, I'm trying to have a plan. So I got to know what in the heck is tangent. So I take a look up here. Oh, yeah, tangent. Tangent is sine over cosine. So if I can get these things as sine over cosine, I'm going to be good to go. I'm going to have tangent. So as I take a look, I already got a sine, but then I got this secant here. So what I want to do is I want to try to change secant in terms of sines and cosines. So what do you guys remember as secant being? What is that guy? Yeah, so if I take a look, secant is 1 over cosine here. Okay, so I'm going to go ahead and change that. And now that's times the sine of theta. Well, if I have 1 over cosine times sine, think of fractions being multiplied together. You multiply the tops and the bottoms. This ends up to be sine over cosine. And we know what sine over cosine is, right? What's sine over cosine? Tangent. And there we go. We just established the identity. Worked out. I got the left side to look like the right side. All right, all right. Do we have any questions there? It's not so bad. Let me make this a little bigger so we can see it here in class. All right, so I take a look at the next one. I've got sine times the quantity, cotangent plus tangent, and that's supposed to equal secant. Remember what secant is. We just did that one, right? Secant is 1 over cosine. So if I can get 1 over cosine on the left side, I'm going to be good to go. All right, so I take a look. Suggestions, what do you think we should do here? I've got sine of theta times this quantity. You normally do when you see a quantity like that. Go ahead and distribute it. So I'm going to go ahead and take sine times both of these guys. All right, so I've got sine of theta, cotangent of theta, plus, and then I've got sine of theta times the tangent of theta. And we're trying to stay on this side. All right, so remember what secant is. Secant is 1 over cosine. I don't see a single cosine right now, do you? So we need to start seeing some cosines. All right, do you guys see anything that we can change so it turns into a cosine of some sort? What do you guys see? What's that? Cotangent? Yeah. Yeah, cotangent is cosine over sine. And then what about tangent? What's tangent? Tangent's what? Sine over cosine? You guys okay with that? All right, so I just changed cotangent to cosine over sine and tangent to sine over cosine. All right, so when I take a look, well, what's going to happen when I take sine times cosine over sine? Yeah, these guys are going to cancel out. And that leaves me with just cosine. And now when I take sine times sine, that ends up to be sine squared over cosine. Okay, so far so good. Well, now I take a look. I have secant over here, right? Which is 1 over cosine. I'm kind of on my way. Well, now I'm thinking, hey, there's just one thing over here. I want to put these two things together to make it one thing, right? So if I'm adding and subtracting fractions together, what do you guys always need? A common denominator. So I take a look. I got 1 in cosine. I need another cosine here. So what I'm going to do is I'm going to multiply this guy here, top and bottom, by cosine. Okay? So cosine times cosine is cosine squared plus a sine squared And now that's all over cosine. So now I've been able to put these two fractions as one big fraction. All right, we're almost there, guys. You guys see what we can do now? What's that? Cross out the cosines? No, don't do that. That's a good guess. Look at these squared things. I got cosine squared plus sine squared. When you guys start seeing those squared terms, I want you to start looking at your Pythagorean identities, right? Do you see cosine squared plus sine squared somewhere up there? This guy right here, right? Cosine squared plus sine squared is the same thing as sine squared plus cosine squared, and we should know that's equal to, that's 1. So this whole thing right here is a Pythagorean identity, and that's equal to 1. So we get 1 over cosine, which is secant. Look at that. We turned that whole mess over there into secant. So we just proved this left side was equal to that right side. It's fun, right? It's like a little puzzle. Trying to get these puzzle pieces all fit. Right? Yeah.
Well, how did you get cosine squared for...
So here we're trying to put these two together.
Yeah.
So we needed common denominators, so we multiplied this guy top and bottom by cosine. So cosine times cosine is cosine squared over cosine. And now the denominators are the same, so we can put them together. Okay, we just add the tops. And you're adding fractions together. All right. Guys, we got about 3 more. That's it. And they'll go pretty fast. All right. Any other questions? Great question. All righty. Here we go, y'all. I got example 3. I've got secant plus tangent and then times the quantity secant minus tangent. All right. What does your heart tell you to do? Listen to your heart. When you have a quantity times a quantity, what should we do? Yeah, that 4-letter F word you can say math class. First outers enters last. Go ahead and FOIL that thing. We'll see what happens. So I've got secant times secant. That's secant squared. I've got secant times negative tangent. So I'm going to write that as negative tangent secant. And now I've got positive tangent times secant. So that's positive tangent secant. And then last but not least, I got tangent times negative tangent. That gives me negative tangent squared. So far, so good? So as I take a look, what happens in the middle? What's negative tangent secant plus tangent secant? Yeah, those guys cancel. Now understand that, you know, if you had secant tangent, that's the same thing, right? Like that's 2 times 3 or 3 times 2. It doesn't matter how you order it. So now we have is secant squared minus tangent squared. And again, we're trying to get that to be 1. Again, if you guys start seeing these trig identities, you start seeing these squared terms, I want you to go back and look at that front page. I see secant squared minus tangent squared. So I go over here and I say, oh yeah, I got tangent squared plus 1 is equal to secant squared. I got one of those guys. I can use some substitution here. Okay, so off to the side, I'm going to write that up here so we can see it. On the front, it was tangent squared plus 1 is secant squared. So what I see is like, well, this guy is equal to this guy. So I can go ahead and use substitution and get rid of that thing. Okay, so secant squared is the same thing as tangent squared plus 1. And then I have this minus tangent squared. You guys okay with that? So again, you start seeing these squared terms, start looking at those Pythagorean identities. Last but not least, I got tangent squared minus tangent squared. Those guys are going to cancel. And then we get 1 equals 1. Check. Works out perfect. Look at that. You guys have any questions with that one? People at home, any questions? We got a few people with their cameras on. No questions, y'all. All right, we got 2 more. Here we go. Number 4. I got secant over cosecant plus sine over cosine equals 2 tangent. Always have a plan, right? Always know what you're trying to figure out. What is tangent? Yeah, so if I could get 2 sine over cosines, I'm going to be good to go. Right? So that's our plan. All right, so I got my little line. I don't want to cross over. What I'm saying is don't subtract this over. We don't want to do that. So I take a look. First thing I know is, well, I know what this guy is. Tangent plus cosine, or excuse me, sine over cosine that is tangent. So I'm like halfway there, right? So as I take a look, now I got this guy. Well, any suggestions on what we can do with secant over cosecant? Bless you. Remember what we're trying to get. We're trying to get 2 tangents. I got one of them right now. I need one more. I need one more sine over cosine. So any suggestions what to do with secant over cosecant? Johnny?
Secant could be 1 over cosecant.
Okay, so secant is 1 over cosine. And what's cosecant?
That one is 1 over cosine.
Perfect. All right, so now we got that thing in terms of sines and cosines, right? And now, do you guys remember what to do with, like, when you got a fraction over a fraction? Fraction over fraction multiplied by the reciprocal. Very good. Okay, so I'm going to take this 1 over sine and just flip it. All right, that allows me to simplify it. So basically multiply by sine over 1, or just sine, so that these guys cancel. And now when I take these 2 fractions together and multiply, I get sine times 1 is sine, and then 1 times cosine is cosine. So I get sine over cosine. Look at that. Sine over cosine we know is tangent. And now we have that tangent plus tangent, which gives me 2 tangents. Check it off. That's not so bad. Have a plan, understand where you're trying to get. I always look on this side and say, well, what is tangent? Tangent sine over cosine. So if I can get things in terms of sines and cosines, I can change those to tangent, and I'm good to go. Okay? That one right away, we could change. This one, Johnny G said, hey, let's change that to 1 over cosine, 1 over sine, and now we can simplify that. All right, we got one more, ladies and gentlemen. The last one. Holy cow, I got 1 plus tangent over 1 plus cotangent equals tangent. We're going to turn this big mess into just tangent. What do you think? How do we do it? What's out of place right now? If I just want tangent. The cotangent? Is that what you said? Yeah, so let's get rid of cotangent. This guy right here, let's get rid of that guy. What do you want to make it? What is cotangent? Because remember, we want tangent. Yeah, this is 1 over tangent. So now I've got all tangents over there. Okay. Well, this is what we call a mixed quotient, where you have like a big fraction, and then inside of that you got like whole numbers and another fraction. Okay, and we did this back in the appendix when we had something like this, 1 over x, and then, or 1 plus x over 1 plus 1 over x. We have something like this, we want to get rid of this denominator, in this case, tangent. So the little trick we talked about here was we multiply by this LCD, this guy right here, and we do it to everything. So to get rid of this tangent, to simplify this a little bit, we multiply by the common denominator. And you really do it top and bottom. So you multiply top and bottom by tan. Okay? And when you have multiple terms, you got to distribute. So I always just put it next to everything. So tangent of theta next to everything. So I've multiplied everything by that LCD. And we did math magic. If you remember, I go do-do-do-do-do. And then everything that's highlighted is going to disappear. It's going to be magic. So as I take a look, I got tangent times 1 is tangent. Tangent times tangent, we know, is tangent squared. Tangent times 1 is tangent. And then 1 over tangent times tangent, those guys disappear and turns into 1. So I get tangent plus 1 on the bottom. Believe it or not, we only have 2 more steps, guys. Okay, 2 more steps. Does anybody have one of the steps? Any ideas? We're going to eventually do some reducing here. But we got to do something else before we just start crossing things out. Remember, if you are crossing out like binomials, you can reduce binomials if they're exactly the same. There's one little thing we got to do to the top. People at home, if you got it, use your chat, use your mic. What can we do to the top? I've got tangent plus tangent squared. Binomials reduce binomials if they're exactly the same. Any ideas? My question is, what can we do with this guy? Good guess, not square root. This is called brainstorming. We're just throwing out ideas right now. I'll give you a hint. Starts with an F. Not FOIL. Factor. What can we factor out? Yeah, we can factor a GCF. So I'm going to write over here. I'm going to take out a tangent. And what that gives me right here is 1. And then take a tangent away from tangent squared. That leaves me 1 tangent there. And now that's going to be all over tangent of theta plus 1. Understand, tangent of theta plus 1 is the same thing as 1 plus tangent, so these guys cancel. They're the same thing, like 1 plus x is the same thing as x plus 1. And now we're left with tangent of theta equals tangent of theta. Look at that. Check. So we just established the identity that this little fraction is equal to that little guy, tangent.